Welcome to the session. Continuation of chapter 2, that is sinusoidal steady state analysis. With respect to chapter 2, I'm starting lecture 2. In the previous session, I given some introduction with respect to sinusoidal steady state analysis. In this session, mainly how to concentrate for a given waveform or for a given function, how to calculate average and RMS values, then how to define the average value and how to define RMS value. First, we have to concentrate what the definition of average values is, how it is defined. I think all of you well know this. The average value is defined based on charge transfer in a circuit. Then if you see the definition of average value, if circuit is connected to DC source, because of this DC source, the current is flowing. When the current is flowing, a certain amount of charge is transferred to the circuit in a given time. Whenever DC source is connected, for a given time, a certain amount of charge is transferred. Same circuit, this is the circuit. First, I connected across DC source. Whenever across DC source is connected, let during time t, Q charge is transferred. That is Q equal to IT. During time t. Now, you have to connect the same circuit across AC source. The same circuit is connected across AC source. And you have to adjust this AC source. In such a way that the amount of charge transfer is equal to the amount transferred for DC supply. The value of AC source is adjusted such that the same amount of charge transferred into a circuit. Whatever the value we are adjusted, whatever this AC source is adjusted to get Q equal to QDC, this is QDC, that value is called average value. This is the fundamental definition of average values. We are not changing the circuit. This circuit and this circuit is same. First, I connected DC source. Whenever DC source is connected, there is some charge is transferred. Now, same circuit I connected across AC source. You have to adjust this AC source in such a way that Q equal to QDC. That whatever the value we are adjusted, that value is called average. That's why I'm telling that the average value is defined based on the charge transfer in a circuit. Based on charge transfer in a circuit, we are defining the average. But RMS value concept is different. RMS value is defined based on the heat dissipation. But average value is defined based on the charge transfer. And you have to see one more definition for average value. The average value is steady equation value of time varying waveform, which could also transfer the same amount of charge as given by the original waveform of a definite period of time. That means if there is an oscillating waveform, this is the time varying waveform, you have to take this is the average value, but this quantity must to transfer the same amount of charge, whatever the charge is transferred by the time varying wave. Then only it is treated as the average. If this time varying waveform is transferring some charge now, if this quantities, this steady equation is also transfer the same quantity of charge, then we can say that this is the average value. Now you have to see this only definitions. But mainly for competitive exam point of view, the calculations are important. How to calculate the average value. But point to remember, the average value is also called mean value. Calculate mean value means you have to calculate the average values. How to calculate the average. Any symmetrical waveform. Symmetrical waveform in the sense, positive area, negative area is equal. Positive area, negative area is equal. The average value of any symmetrical wave for a full cycle is always 0. You take any symmetrical waveform for one cycle, then positive area equal to negative area, then what is its average value? The average value is 0. This point also you have. Any symmetrical waveform, If the positive area equal to negative area, then whose average value equal to say, whose average value to say. With this knowledge, how to see, how to calculate the average value of any function. Then how we can calculate the average value? All of you well known, even in mathematics also you studied about the calculation of this average value. Once again, you have to concentrate in AC analysis, even not only for network theory point of view, in other subjects point of view, also how to calculate the average value, that is very important. Even this knowledge is important in power electronics. This knowledge is important in measurements also. Okay, that you have to consider. The average value or mean value. The average value, or it is also called mean value. It's also called mean value, is calculated by using integration for a particular function 1 by t integral 0 to t f of t. If any function is given, how to define the average value. But this I written in terms of t axis. You write the same formula in omega t axis, friends. Then replace t by omega t. If replace t by omega t, t cancel, 1 equal to omega. What is omega equal to 2 pi? Then 1 by f equal to 2 pi. How you can write 1 by f equal to t? That is, if you have to write this formula in omega t axis, replace t by 2 pi. You can also write average value equal to 1 by 2 pi integral 0 to 2 pi f of omega t d omega t. This is in omega t axis. In omega t axis, how we can write 1 by 2 pi integral 0 to 2 pi f of omega t d omega. That is, you can write like this. This is in omega t axis. I am replacing t by omega t. This you are writing in t axis. Simply you can write like this. This also equal to 1 by t integral. How to take the difference between upper limit and lower limit. This is f of t d. This indicates difference between upper limit and lower limit. This indicates difference between upper and lower limit. Upper and lower limit. This indicates the difference between upper. And one more important observation that you have to concentrate. For example, we know that I equal to dq by dt. I equal to dq by dt. Shall I write like this? Q equal to integral I dt. Integral I dt. Q equal to integral I dt. That is, integration of current gives the charge. Shall I do like this? Q by t, both sides you divide with t, time period. This is equal to Q. This is equal to average current. This indicates the average current. Area under the curve, this is average current. That means what is the observation here, friends? The I average is proportional to Q. The I average is proportional to Q. This I given the statement. Average current is directly proportional to charge accumulated over time period t. Over a time period t, how much charge is accumulated? That is average current. The average current is directly proportional to charge accumulated over time period t. This important statement that you have to know. But this is one of the formula to calculate the average. Students, concentrate. Just a minute. But where we can use this average value calculation, sir? Here I'm telling that there is average value concept and RMS value concept. But where this average value calculations are required? The average value calculations are used in battery charging, electroplating, electrometallurgical refineries. In these applications, we are specifying the ratings in terms of average values. In electrolysis application, speed control of DC motor with back EMF, that back EMF is also average value. Output performance analysis of rectifiers. We know that in rectifiers output side, if you have to calculate, we are calculating the average voltage, average currents. Output and input performance analysis of choppers and SMPS. In choppers also, input is DC, output is also DC. In those applications also we can use in the analysis of choppers, in the analysis of switched mode power supplies. SMPS in the sense, switched mode power supplies also, we are analyzing in terms of DC. However, in most of electrical engineering applications, directly or indirectly, a heat is generated during conversion and transmission. Hence, in general, RMS value calculations are in. If you see the electrical engineering applications in transmission, what is the power dissipated by resistor? In those calculations, we have to use RMS value calculations. But mainly in these applications only, we are using average value calculations. In most of the electrical engineering applications, because there is heat dissipation. Because of that reason, we are preferring the RMS value calculations. Now we have to see what is the RMS value. The RMS value is also called effective value. RMS value is also called effective value. Then how to define the RMS value? The ideal of effective value arises from the need to measure the effectiveness of a voltage or current source in delivering power to a resistor. Why this RMS value or effective value is defined? It measures the how effectively voltage or current source delivering the power to a resistive load. Because of that reason, the RMS value or effective value is arised. RMS value is defined based on heating effect of the waveform. How we can define the RMS value? The RMS value is defined based on heating effect of the wave. How it is defined, I will explain. But based on the heating effect, it is defined. The voltage or current at which heat dissipation in AC circuit is equal to heat dissipation in DC circuit is called effective value or RMS value. Provided both AC and DC circuits have equal value of resistance and operated for same time. That means you connect the DC supply, operate for some time. How much heat is dissipated? Same load you connect for AC supply, operated for same time. If same power is dissipated, then we can treat it as that is the RMS value of given input. This in detail that I given. This is DC supply. This is the load. Now operate for some time. This one. You have to calculate how much power is dissipated. Same is connected across AC supply. Operated for same time. In such a way that same power is dissipated. Then we can say that that value is the RMS value. The effective value of periodic current is the DC current that delivers the average power to resistor as the periodic current. That is, effective value is the DC current that delivers the same average power to a resistor as the periodic current. As a periodic current, if you apply the AC supply, whatever the power is delivered, the same is delivered by DC, then this is taken as a effective value or RMS value. Okay. That is mainly how to concentrate here. Average value is defined based on the charge transfer. RMS value is defined based on the heat dissipation. Before this, how to calculate RMS values? This point also you have to remember, students, with respect to average value. We can also write one more formula for average value. Average value equal to area under curve by time duration. Area under curve. Just like this. Area under the curve, integration. Area under curve by time duration is also equal to average value. Area under curve by time duration. This is one more formula for average value. See, for example, if it is one function like this is f of t, we drawing with respect to t. This is the one curve. how to calculate the area under this curve. Let the time duration is t1 to t2. Then how to calculate average of this curve? Area by what the time duration? T2, t1 to t2, no? That is t2 minus t. This is a calculation of average. Yes, this formula also you have. But here I am defining the RMS value. The RMS value is defined based on the heat distribution. Now the question is where you can use this RMS value representation. Where we are using this RMS value representation. You know this? When a sinusoidal voltage or current is specified, it is often in terms of its maximum value or RMS value, since its average value is. For example, if any sinusoidal waveform is given, you have to specify the sinusoidal using the peak values or using the RMS values. We don't use any average values now because of average value 0. It's a symmetrical waveform. Average value 0. That's why generally any sinusoidal voltage or currents are specified in terms of peak values or specified in terms of RMS values. But these are not specified with respect to average values. Why it is not specified with respect to average values? The average value is 0. Clear? So for example, a sinusoidal voltage of 10 sin omega t means it is specifying with respect to peak value. A single phase 200 volts 50 hertz, that means it is specifying with respect to RMS value. It's not average. In this application, we are using the specification of RMS values. The power industries specify phasor magnitude in terms of their RMS values rather than the peak values. For example, in power industry, if the voltage is specified like this 200 at angle of 30 degrees, what is 200 volt generally, unless otherwise specified, you have to take the RMS value. In power industries, specify the phasor magnitude in terms of RMS values instead of peak values. If they given it is a peak value, then only you take peak value, sir. If they are not specifying is it a peak value or RMS value, in phasor notation, directly you have to take that is the RMS value. One more application. We know that in domestic application, we are getting the power 220 volts or 230 volts at a voltage of 220 volts or 230 volts. What the 220 volts or 230 volts indicates? This is RMS value. Single phase 220 volts now. What is the 220 volts? Unless otherwise specified, that is the RMS value. In different applications, we are using this RMS value representation. A single phase 50 hertz 220 volts available at every household is the RMS value of the voltage from the power company. This 220 volts is which values are? Is the RMS value. Even 3 phase also. 3 phase 50 hertz 415 volts. This is also which value? RMS value. But it is a line to line RMS. Unless otherwise specified, you have to take that is the line to line RMS value. You have to take the line to line RMS value. Clear? Not only this, in most of the power analysis, we have to represent voltage and currents, their RMS values only. For example, P equal to VI cos phi, sir. P equal to VI cos phi. In this calculation also, voltage is RMS value, current is also RMS value. P equal to I square R. In this calculation also, P equal to V square by R. In this calculation also, currents and voltages are RMS values. Because power is dissipating in the form of heat. The elements which dissipate the power in the form of heat, in those elements, we have to use power calculation, you have to use RMS value, don't use average value. This statement you have to remember. AC analog voltmeters and ammeters, you know that. You take the MI meter, EDM meter, moving iron meter, electrodynamometer, all these measures which value? RMS value. Because those are designed to measure the RMS value. Those are designed to measure the RMS value. AC analog voltmeters and ammeters. I'm not talking about DC meter. PMMC is average value. I'm talking about AC meter. AC analog voltmeters and ammeters are designed to read directly the RMS values of voltage and currents. These applications, we are using RMS value representation. Now, how to see how to calculate the RMS values, the calculation of RMS values. For any function, how to calculate RMS value? You have to take either time domain or that is time domain in the sense t axis or omega t axis. If you take t axis, the RMS value are effective values. The RMS value, or it is also called effective value. Effective value equal to 1 by t integral 0 to t f of t whole square dt whole to the power of 1 by 2. RMS stands for root mean square. Root mean square value. Root mean square value. The another name for RMS value is effective value. We can also calculate RMS value for any function in terms of omega t axis. I am defining 1 by 2 pi integral 0 to 2 pi f of omega t whole square d omega t whole to the power of 1. If it is asked, we can also write like this. This same formula we can write like this. 1 by t integral over t f of t whole square dt whole to the power of 1 by 2. This is difference between upper limit and lower. This indicates difference between upper limit and lower. Upper limit and lower. This indicates difference between upper limit. This is root mean square. How to define mean square value? Mean square value. If it is asked to calculate mean square value, mean square means don't take root, don't take square root. Mean square value. Root mean square means you take root. Mean square means without root. Then how to calculate mean square value? 1 by t integral 0 to t f of t whole square dt. This is called mean square value. Mean square means don't take the square. Root mean square means you take the square. This is important observation. Clear, sir? Now you have to concentrate. For example, if I of t is the periodic waveform, if I of t is periodic function, If I of t is periodic function, how to calculate power dissipation? P of t equal to I of t whole square into R. This gives the instantaneous power dissipation. I of t whole square into R. Then what this power gives? Instantaneous power calculation. Instantaneous power. Instantaneous power. What is the average power? How to calculate the average power? Then average power equal to 1 by t integral 0 to t I of t whole square into R into dt. 1 by t integral 0 to t I of t whole square into R into dt. This is average power 1 by t I of t whole square into R into, where R is constant, R into 1 by t integral 0 to t I of t whole square into dt. What this value indicates, friends? What this value? Is it a root mean square value or mean square value? It is a mean square value of current. Therefore, R into I RMS square. Square now, I RMS. Therefore, average power equal to I RMS square into R. Average power equal to, this is P equal to I RMS square. Very important observation here, sir. The power is average power, but average power is given by RMS current, not average current. This is important observation. Average power is given by RMS current, not the average current. Then P average equal to I RMS square into R. Because the element which causes the power loss in the form of heat, those elements, to calculate the power, you have to use RMS values. Don't use average values. That is I RMS square into R. For example, if it is a constant DC current, it is given. For example, if it is a constant DC current, like this. If it is a constant DC current, average and RMS values are equal. For a constant DC current, sir, then how to write P equal to I square R? For example, if any current is like this, I told already, it is a constant DC current. And this is the I current. What is the average of this? I. What is the RMS of this also? I. That's why if any constant DC current is given, then it is I square R. For any periodic waveform or for any waveform, this I RMS square into R. For a constant current, I square into R, where I is the constant current, but that is equal to average value under R. And I already told that even in power calculation also, P equal to VI cos pi. Na? P equal to VI cos pi. V is RMS values. I is also RMS value. Later in the power calculation, I will explain. But P is not RMS value. P is average value. We don't have any concept of RMS power. We have the concept of average power only. We don't have any concept of RMS power source. VI cos pi is which power? This is the average power, not RMS power. There is no concept of RMS power, but average power is concept is there. But the average power is given by RMS current and RMS voltage. V is RMS value, I is RMS value, but VI cos pi is not. Sir, how to say that it is average value, sir? See, for example, V equal to, later in the power calculation I will explain, V equal to Vm sin omega. I equal to Im sin omega t minus pi. If you want to calculate, P equal to integral Vi d omega. Integration of power. Sorry. This is instantaneous power. Instantaneous power. This is instantaneous power. What is instantaneous power? The instantaneous power equal to V into I. Now, you find the average value of instantaneous power. 1 by 2 pi integral 0 to 2 pi Vi d omega t. You multiply these two and simplify, find the average value, we can get Vi cos pi. How we are getting this Vi cos pi? By calculating average value, not by calculating RMS value. We are getting this Vi cos pi by calculation of average value, not by calculation of RMS value, sir. That's why this Vi cos pi is not a, this active power, na, it is not a RMS power. We don't have any concept of RMS power. So only average power, but that average power is given by RMS voltage and RMS current. RMS voltage and RMS current. That point you have to answer. Clear? If it is a constant current, average and RMS values are equal, then you have to write I square. If any waveform is given, you have to calculate the power is I RMS square into R, not I average square. But point to remember, there is no concept of RMS power. But average power is given by which current, friends? RMS current, and it is given by RMS voltage. Once you know the average and RMS values, we have to define the form factor. How to define form factor, friends? The form factor equal to RMS value by average value. RMS value by average. What is the significance of this form factor? I will explain. This is RMS value by average. Next, how to define the peak factor? For any waveform, how to calculate peak factor? That is peak value by RMS value. You have to define the peak factor equal to, that is peak value by RMS value. Peak value by. This is form factor, this peak. And now the question is, see, for example, V equal to 3 plus 4 root 2 sin omega. For example, this is V equal to 3 plus 4 root 2 sin omega. This 3 is there now. This 3 value. This is average value. This 4 root 2, you have to write 4 root 2 by root 2. This is the RMS value of AC. This is RMS value of AC. If you calculate square root 3 square plus 4 root 2 by root 2 whole square. Later I will give this formula. This is RMS value. This is RMS. This is how much you can get? 5 volts you can. How we can get this 5 volts, you tell me? Sorry, this is 5 volts. This is how much? 4 volts. Shall I write like this? 4 volts equal to square root 5 square minus 3 square. That is 20. 5 square is which one? RMS value square. 3 square is which one? Average square. That means from total RMS, if you subtract average, you get only, you can get RMS value of AC. Total RMS. RMS includes DC plus AC. Average is only DC. But RMS value of AC is only AC. How we are getting RMS value of AC, sir? From total RMS, if you subtract average value, we are getting RMS value of AC. This I am writing. The RMS value of AC equal to square root total RMS square minus average. Then I have to define ripple factor. Ripple factor. What is the ripple factor? Square root 2 by 2 into 1 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 by 2 into RMS ripple factor equal to RMS value of AC by RMS value of AC by average value. Shall I write like this, friends? Here I am explaining what is the significance of form factor. What is the RMS value of AC? RMS square minus average square by average. Simplify this, square root. You bring the average into the square root. RMS by average whole square minus 1. Whole square minus 1. What is the RMS by average? Form factor. This is equal to square root form factor square minus 1. Therefore, the ripple factor RF equal to, how to write the ripple factor RF equal to square root form factor square minus 1. This is the relation between form factor and. Now I am asking one question. For pure DC, what is the form factor? For pure DC, what is the form factor? Come on, for pure DC, I told already now. For pure DC, what is the form factor? Unity. If form factor is unity, for pure DC, form factor is 1. Then what is the ripple factor? 0. That means form factor and ripple factor decides the quality of the DC wave. Form factor and ripple factor decides the quality of DC wave. This is very important. Pure DC, I am telling that form factor is unity. Means there is no any AC component in the DC. Ripples are 0. What do you mean by ripples? If any DC component consists of AC component, those are treated as ripples. Form factor is 1 means pure DC. Pure DC means there is no ripples. That means that is the significance of the form factor and ripple factor, which decides the quality of DC wave. If any DC waveform is high quality, pure DC, then there is no ripples. In any DC waveform, ripples are increases. The quality of DC waveform is reduces. That's why that is the significance of form factor and ripple factor. Form factor and ripple factor decides the quality of DC. Decides the quality of DC. Here is some introduction with respect to average and RMS values. Now how to explain for different waveforms how to calculate average and RMS values. For this, all of you well know how to calculate this average and RMS values. Just a minute. For this, I have to give one more observation. Slide. The point to remember here, friends. Note point. Pure DC means only DC. AC equal to 0. Pulsating DC means pulsating DC. DC plus AC. If any DC component consists of AC component, this is called ripple. This is a pulsating DC. And one more point to remember, RMS value, that is total RMS value, gives the information about or RMS value consists of AC plus DC. If DC is not present, only AC. RMS value gives the information about only AC or AC plus DC. Average value give information about only DC, RMS value of AC, yes friends, RMS value of AC gives information about only AC. RMS value tells about only AC or AC plus DC. Only AC means if there is no DC. If there is no DC, then it gives only AC. That is the meaning. If it consists of AC plus DC, then RMS value includes AC plus DC. Just like this. I calculated RMS value now. It consists of DC plus AC. That's why DC AC. Average value is only DC. RMS value of AC is only AC. This is the significance of RMS value, average value, and RMS value of. With this knowledge, start with how to calculate the average and RMS values of sinusoidal wave. Calculation of average value and RMS. Come on, do this. Direct formulas also you know, but I'm explaining how to calculate. Let's consider a sinusoidal waveform. This you have to take. This is pi. This is 2 pi omega t axis. The amplitude is Vm, positive amplitude. The negative amplitude is minus. This is minus. But it is a symmetrical waveform. Positive area equal to negative area. For this waveform, in one cycle, can you tell what is the average value in one cycle? And what is this function V equal to Vm sin omega? Sinusoidal function V equal to Vm sin. Can anybody tell what the average value in one cycle? Average value in one cycle is equal to 0. What is the average value for half cycle? Average value for half cycle. If you calculate average value for half cycle only you take like this. Then V average equal to 1 by pi integral 0 to pi Vm sin omega t d omega t. Integrate and substitute the limits. Then V average is equal to, we can get 2 Vm by pi. This is for average value in half cycle. Next, what is the RMS value? RMS value. RMS value is root mean square value. Is a root mean square value. If you calculate this, 1 by pi integral 0 to pi square the function Vm square sin square omega t d omega t whole to the power of 1. Now integrate and substitute the limits. We can get RMS value equal to Vm by root. I already told for a sine wave, what is the RMS value? Vm by. How we can get? Like this, we can solve. This is RMS. For sine wave, average value 0 in one cycle, but half cycle 2 Vm by pi. RMS value equal to Vm by. But if you are feeling this integration is difficult, this formula directly remember, students. But this formula is applicable for sinusoidal shape, for sinusoidal function, for sinusoidal waves. How to write average values and RMS values directly? You have to calculate average value like this. V average, average, generalized formula. Average equal to Vm by t cos of upper limit minus cos of lower limit. If voltage function is given, take Vm. If current function is given, take Im. How to calculate RMS value? Vm by root 2t. You have to write Vm by root 2t, upper limit minus lower limit, direct formulas without integration, how to apply formula I'm explaining. But these formulas are applicable only for sinusoidal shapes. 1 by 2 into sine of 2 into lower limit minus sine of 2 into upper limit. How to write? Whole to the power of 1 by. This is the formula. Vm by root 2t, upper limit minus lower limit, plus 1 by 2 into sine of 2 into lower limit minus sine of 2 into upper limit, whole to the power of 1 by 2. Apply this formula for this case. Substitute upper limits and lower limits here. You check it. Are you getting Vm by root 2 or not? That I am leaving for you. Apply this formula for this case. Substitute upper limit and lower limit here. Are you getting this answer or not? Check it. That I am leaving for you. But this direct formulas you have to apply only for sinusoidal shapes, not for every waveform. Please check it. Just a minute. Please check it. Students, are you got this? Substituting this, are you getting or not? But this direct formulas, how to calculate average and RMS values for a given sinusoidal functions. But all the cases it is not applicable. Only for sinusoidal shapes only it is applicable. That you have to consider. Once you know the average and RMS values for any sinusoidal waveform, how to calculate the form factor. For a sinusoidal waveform, form factor equal to RMS by average. But this very important observation here. During calculation of RMS form factor for sinusoidal function, don't use average value of one cycle. If you use the average value of one cycle, we can get infinity. Means we are not defining. It's not possible to define if you take one cycle. That's why to define the form factor of sine wave, let assume that negative as a positive, or you take the half cycle average value. Then what is the RMS value? Vm by root 2. What is the average value? 2 Vm by pi. Then what you can get, friends? Pi by 2 root. Pi by 2 root 2 value is 1.1. Then form factor of sine wave. Form factor of sine wave is 1.1. This you have to consider. This pi by 2 root 2 that equal to 1.1. Then how to calculate peak factors, friends? How to calculate peak factors? Peak value by RMS. Peak value by RMS. What is the peak value? Vm. What is the RMS value? Vm by root. This is equal to root 2. That is 1.414. This, what is the average and RMS value of sine wave? See, for different waveforms. This is pulsating DC. If the waveform is given like this, then what is the average and RMS value? Try it. Come on, do it, sir. For every waveform, you have to know the average and RMS values. This is pi. This is 2 pi. This is 3 pi. This is omega t axis. It may be current is given or voltage given. Same method you have to. Can you do the average value? First, I am calculating average value. Average value equal. This is just like half. It is a half wave rectifier out. What is the time period of this waveform? 2 pi. How to calculate time period? I will explain. 2 pi integral 0 to pi Vm sin omega t d omega. But pi to 2 pi is 0. 0 d. Correct? I am explaining how to calculate average. Then what is average value? 1 by 2 pi integral 0 to pi Vm sin omega t d. Then use this formula. Direct. Substitute here upper limit and lower limit. Simplify that. We can get directly I am writing V average equal to Vm by pi. This we get. Or otherwise integrate and substitute the limits. Vm. Then how to calculate RMS of this one, students? The RMS value equal 1 by 2 pi integral 0 to pi Vm square sin square omega t d omega t whole to the power of 1. Use this formula. Substitute upper limit and lower limit here. We can get answer. Or otherwise integrate and substitute the limits here. Then what is the VRMS of this waveform? Vm by 2 we can. If it is the current, Im by 2. If it is voltage, Vm by 2. But here I am explaining with respect to voltage. This is pulse weighting DC. This is the pulse weighting DC. And you know that this is half wave diode rectifier out. Single phase half wave diode rectifier out. Now, how to calculate form factor of this one steps? Form factor equal to RMS by average. RMS is how much? Vm by 2. Average is how much? Vm by pi. Pi by 2. 1.57. 1.57. What is the peak factor of this? What is the peak factor of this? RMS by peak factor. Peak value by RMS value. Peak value is the maximum value. Peak value by RMS. Peak is Vm. RMS is Vm by 2. What is the peak factor of this? 2. Like this. Yeah. Can you try for this? Come on, do it. For some waveforms, again, no need to do the calculation. Directly you can remember whatever these waveforms I am giving. For this type of waveforms, not only network theory point of view, in other subjects also these formulas are useful. That's why directly you remember. This is pi, this is 2 pi, this is 3. This is on omega t. Can you try for what is average value? average value equal. The time period is pi only. 1 by pi integral 0 to pi Vm sin omega t dv. Integrate and substitute the limits. Directly I'm writing. Or otherwise, direct formula I given in that upper limit, lower limit you substitute 2 Vm by pi you can. This 2 Vm. For this waveform, you try for RMS value calculation. What are the RMS values? This RMS value equal to 1 by pi integral 0 to pi Vm square sin square omega t. How to calculate RMS? D omega t equal to the power of 1. Then integrate and substitute the limits. What you can get RMS equal to Vm by root. Then you try for form factor VRMS by V average. VRMS by V average. That is 5 by 2 root 2 equal 1.1. 5 by 2 root. For this full, it is a full wave rectifier out. Full wave diode rectifier output 1.1. This is full wave diode rectifier out. This also pulse weighting. This 1.1. What is the peak factor? Peak factor equal to not only average and RMS values, remaining form factor and peak factor also I'm explaining. That is peak value by RMS value, Vm by root. This is equal to root. This is for this waveform, but the average value, but the RMS value. Minimum you try to remember this formula. Next. This is which waveform, students? It is a square wave. It is a square wave. Can you try for what the average and RMS value of this waveform? This is A. Or you take this is Vm. Let's assume that it is a voltage wave. Problem. Voltage waveform or current waveform. This is Vm. This is minus. For this waveform, what is the average value in one cycle? Can anybody? What is the average value in one cycle? In one cycle. The average value in one cycle, positive area equal to negative area. This is equal to 0. What is the average value in half cycle? Average value in half cycle. Half cycle. For periodic waveform, sometimes they will ask the average value for half cycle also. Then it is a Vm. The amplitude is the average in half cycle. Can you try for what is the RMS of this waveform, students? What is the RMS? Simply remember, no need of any derivation. For a square waveform, this is the square waveform. So which waveform? Square wave. For a square wave, RMS value equal to peak value. RMS value equal to peak value, sir. If you want, write 1 by pi, or that given 1 by, this is by 2 pi like this, or 1 by, sorry, 1 by t, 2t, 3t like that it is given. If you calculate the RMS value, then we can get the Vm. If you calculate RMS value, it's throughout for any subject, not only for network theory point of view, even power electrons measurements, other subjects point of view, any students are there, then simply remember this RMS value equal to peak value. By taking the limits, if you calculate, finally you can get this RMS value equal to peak value. In square waveform, RMS value equal to peak value. Next, what is the form factor of square wave? Form factor equal to RMS by average. RMS is Vm. Don't take 0. If you take 0, infinite, we can't define. That's why we are defining for half cycle. This one. This is equal to 1. Form factor is unit. Then what is the peak factor? For a square waveform, what is the peak factor? It's equal to peak value by RMS. Peak value by RMS. What is the peak value, students? Vm. What is the RMS value? Vm. Peak factor equal to. Peak value is Vm. RMS value is also Vm. Then peak factor equal to. That is all. Next. Can you try for this? It's a triangular waveform. Calculate the average and the RMS values. Calculate the average and the RMS. Come on, do it. right? For example, that this is the t-axis. It's a periodic waveform. This is t, 2t, like this it is given. 3t, 4t, like this. That the amplitude is, you take any amplitude you have to take. That this is the A is the amplitude. First, I am calculating average value. I am explaining how you are getting, but final formula is important. Average value equal to what the time period of this? It is a periodic waveform t. 1 by t integral 0 to t. That this is one function. It may be voltage function or current function, whatever. F of t dt. But you have to find what is the expression for this function. Then you find this line equation. One method to calculate this line equation is y equal to mx, because this is a line passing through horizon. In y-axis, what you taken? F of t. What is slope? Slope is y by x, a by t. In x-axis, what you taken? T, a by t into t. A by t into t. Clear? F of t, a by t into t. Or otherwise, every time you don't expect the line passing through horizon. At some other point also they will give. In that case, to find that, you have to apply the line equation. These coordinates are 0, 0. These coordinates are t, a. If it is changing from this, one more method I am explaining. 0, 0. These are the fundamentals. T, a. Then this is x1, this is y1, this is x2, this is y2. How you can apply? Y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x. On y-axis, what you taken? Function f of t. y1 is 0, y2 is y1 0, x2 t, x1 0. In x-axis, what you taken? T. Then also you can get a by t into t. Now you substitute here. 1 by t integral 0 to t, a by t into t. T. But a by t is the constant, that is a by t square. That is integral 0 to t, t dt. What is the integration of t? T square by 2. A by t, t square by 2 squares. Limits are 0 to t. Substitute the limits. A by 2t, a by 2t square, a by 2t square. Limits are t square minus 0. That is a by 2t square into t square. T square cancel. What is the average value? A by 2. Very, very important 5-star gunshot form. If this type of waveform is given, how to find the average value? A by 2. But no need of concentration on the derivation. But finally, how we are getting this average equal. For this waveform, average is important, RMS, because already framed in complex. Then how to calculate RMS values? For this waveform, how to calculate RMS? So, adding the slide. Calculate RMS value. Come on, do it. RMS equal to 1 by t integral 0 to t f of t whole square dt whole to the power of 1. Then substitute the function 1 by t integral 0 to t. What is the function? That is a by t into t. A by t into t whole square dt whole to the power of 1. This I am leaving for you. Just integration only. Then what RMS value you can? A by root 3. Very important 5-star. For this case, RMS value equal to a by root. Average value is a by 2, sir. For this waveform. Directly remember. RMS value is a by root. Once you know the RMS and average values, how to calculate form factor of this wave? Form factor equal to RMS by average. RMS is a by root 3. Average is a by 2. This is equal to 2 by root 3. This is the form. Clear? This is. For this waveform, you try for average and RMS values, right? But one more point you remember, friends. One more method to calculate the average value is area under the curve. Average value is also calculated by using area under the curve. See, for example, you have to calculate average area under the curve. This is triangle. What is the area of the triangle? Half BH. Time period is T. Half into B is how much? T. H is how much? A. By total time period is T. T cancel. What you can get? A by 2. This also method. Average value is not only integration method, you can also calculate average by using area under the curve. Area under the curve gives the average value. Clear? That point also you have to remember. Sometimes just by knowing the area under the curve, we can easily calculate the average. Let for example, this is T, 2T, 3T, 4T, 5T. This is T. At the amplitude is A. Then how to calculate average value? How to calculate average value? One method to calculate average value is integration method. Integration method you have to calculate. Or you can calculate area under the curve. Half into B. B is how much? This is area under the curve. Half into, this is triangle. B into H A by what is the total time period? 2T. Time period is 2T, not T. Total time period is 2T. TT cancel. A by 4, sir. Or by finding the equation of this, you find the integration method. Then also you can get A by 4. Very important. For this waveform, what is the average value? Average value equal to A by 4. You find the equation of the curve and solve by using this method also. Solve by using this method also. We can get A by 4. Next, what is the RMS value? Directly I am writing. RMS value of this waveform equal to A by root 6. I am not doing any derivation. Follow this method. Follow this method. This RMS value, this method. And prove this RMS value equal to A by root 6. Then for this waveform, what is the form factor? The form factor equal to RMS by average. Form factor equal to RMS by RMS by. This is RMS is A by root 6. Average is A by 4. That is 4 by root 6. This also 5-star forms. These two waveforms are very important, already framed in computation. Both are triangular waveforms. Next. This also, it is a pulse waveform. It is a pulse waveform. For this waveform, simply remember, for example, this is on time. This is the total time period. No need to go for integration method. Simply remember like this. How to find average of this waveform? Average value equal to amplitude into on time by total time. Simply remember like this. For a pulse waveform, how to calculate average value? Amplitude into on time by total time. By integration method also you can get, but not required. How to calculate RMS value of this waveform? The RMS value equal to, you take amplitude into square root on time by total time. This is the RMS. Amplitude into square root on time by total time. This is RMS. These two formulas mainly how to remember with respect to pulse wave. Once you know the average and RMS values, how to calculate form factor, that you know, form factor equal to RMS by average. Later on you do that. Leave it. This is the, simply remember, if any pulse waveform is given, how to calculate average and RMS. It is a constant amplitude. There is no change in amplitude. Constant. Otherwise, you apply integration method also. You can get finally, you can get same. Next. Find average and RMS value of this waveform. This I am leaving for you. Can you prove this? Average equal to, you have to calculate average for full cycle. If you calculate average for full cycle, positive area equal negative area, this average is equal to 0. You calculate RMS value, it's just like a triangular waveform, you can get RMS value equal to A by root. This is for full cycle. For full cycle, the average value equal to 0. To try this and calculate what the average and RMS value is. This also I am leaving for you. Can you try for this? What the average and RMS value of this waveform? Come on, do it. Can you try it? So, can you try this, sir? What is your answer? For this, you calculate for full cycle, but this is for half cycle. If you calculate this one for half cycle, you calculate average equal to A by half cycle. You calculate this average half into B into H. Average equal to A by. Can you try this? What is the average average of this one? It's very simple. I told already. Average value is nothing but area under the curve method. Instead of going for integration, go for average value, area under the curve method. This is 1, but this amplitude is 0. That is 0 into 1. Plus, from this point to this point, 1 to 1. Amplitude is 40. 1 into 40. Plus, every rectangle area I am calculating. 2, 2, 3, 1. 1 into, this amplitude is 60. Plus, 3 to 4 is 1. This amplitude is 80. 1 into 80. 4 to 5 is 1. This amplitude is 100. Plus 1 into 100. 5 to 6 is 1. This amplitude is 80. 1 into 80. Plus 6 to 7 is 1. This amplitude is 60. 1 into 60. Plus 7 to 8 is 1. This amplitude is 40. 1 into 40. Clear, friends? If you want clearly, once again I'm writing. Just I'm writing area under the curve. Calculate area under the curve is average 1. From this 0 to 1, there is no output voltage. There is no voltage now. That's why 0 into 1. 0 into 1. 1 to 2, 40. 1 into 40. 2 to 3, 60. 1 into 60. 3 to 4, 80. 1 into 80. 4 to 5, 100. 1 into 100. Plus 5 to 6, 80. 1 into 80. 6 to 7, 60. 1 into 60. 7 to 8, 40. 1 into 40. Correct? 0 into 1. 1 into 40. 1 into 60. 1 into 80. 1 into 100. 1 into 80. 1 into 60. 1 into 40. By total is, the total time is how much? 8 seconds. Total time is 8 seconds. Then what the average value is? If you simplify this, you can get average value equal to approximately, this is 40, this is 60, this is 80, this is 100, 80, 60 plus 40 by 8. Correct? 40, 60, 80, 100, 80, 60, 40. 100, 180, 280, 360, 420, 460. 460 by 8. 8, 5, 40, 8 sevens, 56.5. 57.5 volts. This is average. How to find RMS value? RMS is nothing but a root mean square. Root mean square. Square the mean value. Root mean square. Mean square and square. Shall I write like this? RMS value equal to, how you can calculate RMS? Simply you can do the calculations. RMS value. square root, square all these. 0 square, 40 square, 60 square. This mean values now. 0 square, 40 square, 60 square, 80 square, 100 square. For squares, we are finding the mean value. 80 square, 60 square, 40 square. For squares, we are finding the mean value. Total is how many values? Total time is how much? 8 seconds by 8. 0 square, 40 square, 60 square, 80 square, 100 square, 80 square, 60 square, 40 square. Square root. Root means square value. Simply you can do like this. Then by simplifying this, how much you can get, students? 64.42 volts we can. 64 point. Clear? Like this. This you try for homework for practice. Find the average and RMS values. Right? This is how to write the voltage. This is sinusoidal shape. V equal to Vm sin theta. 100 sin theta or 100 omega t. Vm sin omega t. Vm sin omega. That is 100 sin. You take this, find the average values and RMS value of this wave. Find average and RMS value of this. If any doubt, you can share your doubt in my Telegram channel. Then I will give the details. But try by your own. For this also you try for homework. For this also you try for homework. Find the average and RMS values of different waves. This also you try for homework. Find average and RMS values. Yes, friends, this is about the today's session. How to calculate an average and RMS value. But there is one important formula is there. If any function is given, how to calculate average and RMS value, that I will explain next session. And after completing that, you have to solve some models of questions. Then you go for the phasor representation, fundamentals of phasors. After completing fundamentals of phasors, then directly you go for AC supply is given to resistance, inductor, capacitor, RL, RC, RL series, RL parallel, RC series, RC parallel, RLC series, RLC parallel. That analysis is there. This is about the today's session. Thank you. Any doubt? It's only fundamentals, how to calculate average and RMS. This not only for network theory point of view, for remaining subjects point of view also, this knowledge is important. Thank you.